name is Adam Janensky, and I will be your instructor in statistics this winter. And I'm creating this very short video just to give you a brief introduction to the class and its contents. Will be Statistics by Friedman, Pisani, and Purvis. I think it's a really wonderful book because it will explain to you all the basic concepts of statistics, and it will do so in a manner that should speak to you in the sense that it's full of interesting examples. It doesn't just say, this is what a mean is. There's lots of pictures. And there's lots of illustrations. If you randomly pick a page like I obviously just have, you can see there's a lot more going on than just words. And the other text is this one, Introductory Statistics with R by Dalgard. And this is the book that we'll be using more for the computer side of things. The contents are we're going to discuss exploratory data analysis, sampling and designing experiments. We'll be talking much more about sampling than we will be talking about designing experiments. Confidence intervals and significance tests. This is a very important topic. Statistics is all about describing a set of data by a number or numbers. And that's only half the story. I mean, if I tell you the mean of two people, one is age 0 and one is age 100, is 50, it's the same thing that if I tell you the mean of two people who are age 49 and 51 is 50. But you would clearly, if you had a third person that you wanted to guess, in this second case, you'd be much more sure that his age was around 50 than in the first case. So we're going to discuss confidence intervals and significance tests, which is really a way of saying we have a number, just how sure are we that this number is good? And mean, variance, and other statistics, these are some of the numbers. Hypothesis testing is a way of formally looking at whether certain ideas are true or not. So you use hypothesis testing a lot of times. When you draw a model, you want to test the hypothesis that this model actually makes some sense. And the most common place we're going to test it with is with linear regression. So linear regression is a mathematical method, and the statistic says, how good is this mathematical model in any given case? And then ANOVA analysis of variance is a more sophisticated version of some of the other things we've talked about. And these are the topics I hope to cover. Before I go further, I just want to say that I'm a firm believer that it's more important that you understand something well than you understand a lot of things. So whatever will happen, I should just let you know. And so when we look at objectives, we want to understand these things, but more than just sort of understanding these things abstractly, it will be very important that you be able to use the R computing language in the R environment to do this. So we will be able to use R to implement all these things we've talked about. We'll be able to go further than that and use R to write scripts, which are sort of like programs, but they don't have as much structure. They allow you to change information on the fly. And so you're going to learn how to write scripts to implement studying a given data problem. And finally, we will be able to learn how to use R to create linear models and understand. So this is a program called RStudio you're now looking at. And RStudio is something you will have on your computer when you take this class. It's the standard way to run R. This to do, the sort of one of the culminating things we're going to discuss here is creation of linear models. Now, in R, this is a very simple thing. Let's not worry too much about the syntax, but LM means create a linear model. And I want to see how I can predict miles per gallon compared to the other variables using the data of my set. And if I just hit that and run, it's done. And now I say, so I've said, rather than just sort of printing it out, I mean, I could have, if I didn't do this equals, you see on the bottom, if I just had run that command, create the linear model, it would give me the basic information, but by doing it this way, I've created an R object which has all the information, and I can use it again and again. And in particular, now when I call summary, I get a lot of information. I said tells me this is what how the miles per gallon is run, and it gives me the residuals. So in other words, the residuals are the difference between my prediction and what the actual value is. So they didn't do badly. On average, they weren't too bad, and I was never off by more than a range of minus 3.4 to 4.6 miles per gallon. And over here we see here's the coefficients that we get. And we have an intercept term, and here's for all the other variables. And here's our first lesson about statistical models and not saying things, not having to just take things at face. You'll notice that this last column, it just says the probability of greater than t. It means the probability that you would get this t value if the real coefficient is 0. So you can see these numbers are pretty big. So there's, for example, for carburetor, there's an 80% chance you would get this value of carburetor that we got, this estimate, if the true value was 0, because after all, these are statistical estimates. So the long and the short of it is you'll just have to take my word for this, that while via this r squared number, we can see that this data explains the model, we can see we're not actually very sure about any particular coefficient, and we're not sure what it is. So I said, well, let me create another model. Let's see if we can value miles per gallon based just on the cylinder and the horsepower. Now that makes sense. We know that more cylinders and bigger engines, more horsepower, generally means lower miles per gallon. So let's run that and see what happens. So I run the model, and by the way, notice how quick this is. I just did it and it's done. And now I hit the summary, and what do I get? The residuals are relatively similar, somewhat bigger. On the other hand, now this number of cylinders is almost definitely, it says the probability that you would have this coefficient, and notice it's negative, which is what you'd expect. The more cylinders, the lower miles per gallon. So essentially the probability is 0, that it would be not 0. And horsepower is some significant, though it's not as significant. The R squared has gone down. We've explained a little bit less of the data, but the probability that these are the things that are explaining it is pretty high. And so that's all I really wanted. All right, so that's pretty much it. I'm looking forward to seeing you this winter, and hopefully this has given you some idea of what you can look forward to. I will see you this winter.